Newton's laws of motion. Badminton is a team or individual sport in which players hit the shuttlecock, also known as the shuttle, across the net. It is a competitive sport in which players need to keep the shuttle off their side of the court. If one player hits the shuttle across the net and the other player is not able to return it, the player who hit it wins. In this video, we will talk about how badminton relates to Newton's 3 laws of motion. Hello and welcome back to Sports First. I'm Pranav Shankar and I will be your host today. Newton's 3 laws are everywhere around us. We can see them in action when driving, sleeping, or playing. During today's episode, we will dive into the relationship between Newton's 3 laws and the sport badminton. We can see them during serves, while rallying, and even picking up the racket.
First, Newton's first law of motion. Newton's first law states that when an object is in constant motion or in rest, it will remain at rest or in motion unless an unbalanced force is applied to the object.
Newton's first law can be seen in a badminton serve. The previous video is represented by the following force diagram. The forces present during a badminton serve include the applied force, air resistance, and gravity. The applied force is the unbalanced force, which is why the shuttle propels forward in the video. In this part of the second video, the ball stops when it reaches peak point. The time when the ball reaches its highest point is shown in this force diagram. At this point, there are two balanced forces, air resistance and gravity. Because they are balanced, the shuttle stops for a brief moment before falling to the ground. Newton's first law of motion can be seen in all of the videos and force diagrams. Everything has the tendency to remain at motion or rest, including the badminton shuttle or the racket. For example, when picking up the racket, you are bringing it into motion and you need force to pick it up. Newton's second law. Newton's second law states that force is equal to mass multiplied by acceleration. Using this law, we can find net force, mass, and the acceleration. In the first video, we can see that the shuttle does not travel as far as it does in the second video. This is because the acceleration of the shuttle in both videos are different. In order to understand this, let's look at the math behind it. Using Newton's second law, we know that force is equal to mass into acceleration. So, applying this to badminton, the mass of the shuttle is 0.46 kilograms and the force applied is 125 newtons. In order to find acceleration, we had to divide the force by the mass. So the acceleration would be 125 newtons divided by 0.46 kilograms. The acceleration would be 271.7 meters per second squared. For the second scenario, the force applied is half of the force applied for the first scenario. The mass of the shuttle is 0.46 kilograms and the force applied is 62.5 newtons. So the acceleration would be 62.5 divided by 0.46, which would get 135.9. The evidence from Newton's second law shows how the law can be applied to the sport of badminton. When a ball has greater acceleration, it means you applied more force. And when a ball has less acceleration, it's because you applied less force. Therefore, using this example shows how mass, acceleration, and net force are all related. Newton's third law. Newton's third law states that every action comes with an equal and opposite reaction. In this part of the video, you can see a slight rebound on the racket. In the following force diagram, you can see that the action force is on the shuttlecock and the reaction force is on the racket. The evidence from the force diagram shows how an action and reaction force are present when you hit the shuttle during a badminton game. Although you may not be able to see the racket bounce back, there is a very small vibration. This is because the shuttlecock has a small mass and therefore gives out less net force. This is why the racket does not show much recoil when it hits the shuttlecock. Thank you for watching.